So please, colleagues, you can start.
Уважаемые коллеги, друзья.
Dear colleagues, dear friends, everyone who is interested in this topic, Industry 4.0, in application to shipbuilding, thank you very much for joining us. I would like to start and to say thank you to Adrian Danier, Director of Nauka и Nov, because Nauka и Nov supported our initiative, and that's why we are organizing the first French-Russian forum for the shipbuilding industry 4.0. And the university, the State Marine Technical University of St. Petersburg is one of the main universities in Russia for this industry, and this is one of the biggest universities in the world of this kind. The topic of our forum is Industry 4.0 in application to the shipbuilding sector, and you know that every notion, every concept passes through the first stage when we learn new terms, and this first stage passed already. These were great new words, and it was related to the fact that we wanted to use new technologies in industry and in shipbuilding. We are now at the second stage, and we are mature enough to organize such a forum. And now we are talking about the real use of concepts of the Industry 4.0. And the words as virtual modeling, integration, digital twins, machine or deep learning, big data, artificial intelligence, which were new to us, are now quite ordinary. And also we can include other terms developed in our shipbuilding industry. I would like to pass the floor to Adrian. I would like to thank once again Nauka и Nov for your participation in the initiative to organize this event.
Thank you very much. It's a real pleasure to be here with you at St. Petersburg, at the St. Petersburg State Maritime University. It is a very important moment for our cooperation with this first French-Russian forum for the shipbuilding industry 4.0. Nauka и Nov is the Center for Technological Cooperation of the French-Russian Chamber of Commerce and Industry. We are dealing with the acceleration and development of the high technology cooperation between the French companies and the Russian industry. We are working extensively on aviation, space, and other sectors, and we hope that today we will open actually more gates for the shipbuilding, because we have to see that in St. Petersburg, in the city founded by Peter the Great, when he wanted to look at shipbuilding industry, he went to Netherlands, not France, unfortunately. And what we can see also is that at the last NEVA exhibition, which is like Navale for the French colleagues, at NEVA exhibition, the largest shipbuilding industry exhibition which takes place in St. Petersburg, we unfortunately do not see yet a French pavilion. But we can see Netherlands pavilion, Italian, South Korean, and so on. France is the European leader in shipbuilding industry. We do have the largest maritime exclusive zone, and we do have a lot of new technology and innovation that can contribute to the Russian shipbuilding civil industry. And I hope that today this forum will allow the French colleagues to look at the potential of the Russian industry, and for the Russian colleagues to identify some interesting partners for your development. We'll cover, as Kirill said, different technology from digital to advanced manufacturing. We'll also focus on the Arctic maritime route, which is a key strategy for Russia, with a very big roadmap of shipbuilding industry following. And we do have also in France innovation for this perspective. And we hope that this third edition will bring many success, and to bring soon a Russian delegation to France and French people to St. Petersburg. So, dear colleagues, we will start now with the first session of our forum, which is dedicated for the digital technology for the shipbuilding industry. And I would like to let ESI Group, a French company specialized in advanced simulation technologies and virtual reality technologies, to show their expertise on the shipbuilding. And we will listen to Mr. Kotov, the General Director of ESI Group in Russia.
I will introduce this group in Russian too. So the presentation is called Analysis of Internal and External Noise and Vibrations in Shipbuilding with the use of ESI VA1 solution. And I now give the floor to Vyacheslav Kotov from ESI Group.
Colleagues from ESI?
Vyacheslav.
Dear colleagues, I would like to show you the presentation on the topic of analysis of internal and external noise and vibrations in shipbuilding with the use of ESI VA1 solution. Just a couple of words on the ESI company. It is a French company, and its subsidiaries are located in more than 40 countries. We have 35 subsidiaries, and our staff is more than 1,200 people. The ESI company was founded in 1973, and we have been the leader in virtual solution and in physics of materials. What are the challenges we face in the sphere of acoustics? As concerning commercial shipping, we talk about reduction of noise and vibration, which are structure-borne and which are transmitted to the passenger cabins, crew cabins. We talk about underwater noise and also standards on noise pollution. And we also talk about insulation, and we can use it to reduce noises and vibration. We also have some requirements for the noise certification, and one of the sources of noises can be the air conditioning system, which can be optimized. As for the naval application, here we see more challenges and tasks. We deal with internal noises and the system of noise and sound insulation for different compartments, sound insulation for air conditioning systems, for air ducts, but we also can add some other tasks related to the application of naval products. These are acoustic signatures of engines, of rotors, of additional turbines. This is the surface signature of the ship, and also the possibility to identify this ship at a distance. So we reduce noises, and we also reduce its general signature. What VA1 can offer? The main task of this solution is to solve the tasks in the whole range of frequencies, starting from low frequencies, and this is shown on the left side. We talk about frequencies up to 20 hertz, but it can go up to 100 or 150 hertz, and we can use the finite element method. In this case, the medium range of frequencies up to 400 or 800 hertz. When we use hybrid methods, the finite element method with the strain energy method, and the last range of frequencies up to 20 kilohertz, we use the strain energy method, and this method can average out the energy by octaves, and it allows us to calculate the highest frequencies. How can we solve the task of calculating acoustics inside the ship? First of all, we need to have the finite element model or CAD model. If we do not have such a model, inside of our software, we have a special marine modeler, which allows to create CAD models based on deck drafts and cross-sections. These models can be uploaded in standard CAD formats. You can see what formats can be uploaded, and you also can upload an finite element method and use it for your analysis. You can see here the division of the ship to different compartments, to different zones. You can see cavities in gray, and also you can see junctions and side walls in red. How, after the creation of the model, it is calculated? First of all, we use noise-absorbing material with panels, if we have such noise-absorbing material. We have the source cavity on the left. Afterwards, we have the base panel, and so we use different insulation materials with this base panel, and afterwards we have the receiving cavity, and we can calculate how the noises and vibrations are transmitted, and we can calculate the resonant path and non-resonant path. We can have different options for the source. The main source is the engine, and for us to be able to model all the calculations, we need to have the finite element model of the engine support to understand how the noise will be transmitted. And this finite element model is interpreted as point forces and acoustic constraints, and this energy is calculated on the structure of the ship. Such calculations allow us to see what is the level of noise loading, starting from the noisiest compartments and ending with the less noisy compartments, for example, the main deck salon. And you can see also the figures for noises in the whole range of frequencies. We can take into account the water loading, which increases the mass of the ship. We consider water as SIF, so this is the semi-infinite space, or as just mass loading on specific zones of the outer skin of the ship. The main task is to evaluate the paths of noise transmission and understand how the noise can go to the crew cabins, for example. The general level of noise is shown on the figure in blue, this blue line, and we also have different paths of transmission. So we analyze the most interesting paths of transmission, and they will be optimized afterwards. We can optimize it with the use of noise-absorbing materials, or by increasing damping, by increasing thickness. We can use different options of insulation materials, and we can just add insulation. We also can replace the material we use in the domain of the dominant noise transmission and reduce noise in the needed area. The material itself is chosen based on the constraints. We have constraints for weight and the cost of materials, and we also look at the transmission losses. You can see the transmission losses at the bottom of the slide, and we want to have the maximum transmission losses in the most noisy compartment. This is the first part related to the internal noises. The second part is related to external noises. So from where we can transmit noises to the external environment. So first of all, this is the vibrating structure, the vibrating outer skin, and here we can analyze velocity and pressure under different frequencies. The second block is the screw, and locally we can analyze in each point what is the level of noise generated by the screw. Except the determination of the noise level at a specific point, we can also look at the direction of this noise. So what will be the frequencies, the directions, and the distances of this noise transmission. And we also can evaluate with the help of the modal analysis how the structure will behave under different frequencies and how the noise will be transmitted at a certain distance. So, for example, we have a 400-meter diameter or 1,200-meter diameter. So we can see the waves and we can understand what a person or an equipment will be able to hear at this diameter. The same for 25 hertz, 40 hertz, etc. So this is the second level of tasks which V1 can help you to solve. This is the evaluation of the external noise and the evaluation of the acoustic signature of a specific ship. And to conclude, I would like to show a number of clients which are using V1 solutions. It is used very actively in Europe, in the USA, in Asia. Our client in Russia is the Rubin company. They are manufacturing submarines. Well, unfortunately, their tasks and the details on their tasks are not available to us. If you want to receive additional information, you can contact them directly. Thank you very much for your attention. We continue, dear colleagues. The second presentation is called A Navigation, Russian Approach to the Autonomous Navigation. And I would like to give the floor to the Center of Promotion of Autonomous Navigation, Marinette Root, and Alexander Pinsky will represent this center. This is a unique Russian project.
Listen to the presentation of Alexander Pinsky, the director, who will introduce the A Navigation, a Russian approach towards autonomous navigation, a unique center of competence. And we listen to you, Alexander.
Thank you very much. Good afternoon, dear colleagues. I'm glad for the opportunity to share information on the developments in this very interesting area. I believe that this topic could be interesting and also promising for cooperation between organizations of our countries. So first of all, a few words about autonomous navigation, or A navigation, as we name it in short way. Autonomous navigation, meaning use of automatically and remotely controlled vessels, is considered as one of the most hot, as most demanded, expected technologies in the maritime industry. Sometimes it is even considered as a new technology revolution. On the one hand, it will significantly increase safety of navigation, eliminating human factor, which is the main cause for incidents on sea. On another hand, it can significantly reduce operational cost of shipping companies, and that's why there is a great interest by ship owners to this technology. Probably this is the first time for many years when ship owners will not pay for additional safety with extra costs. That's why in many countries, actually in all major maritime countries, currently there are different experiments and trials on autonomous navigation. For example, last year, France has reported to the International Maritime Organization, IMO, about the first trial of autonomous vessel. And in Russia this year, we are making a very important step. We are reaching a milestone not only for Russia, but for the global fleet. We are completing the world's largest trial project, and we are starting the national-wide experiment on maritime autonomous surface ships or MAS use. Within this experiment, any shipping company can equip with autonomous navigation systems any ship under the Russian flag and legally operate them in commercial conditions. The trial project, which I mentioned, was started in 2019 when 3 Russian major shipping companies, Rothmar Port, Komplot, and Polar Group, together with technology company, with universities, Russian Maritime Register of Shipping, which is a classification society, international classification society based in Russia, gathered under the umbrella of Marinet with the aim to make possible wide mass operation starting from 2021. So idea is very simple. We believe, and I strongly believe, that new technologies are developing, are maturing not in research labs or in technology companies, but in hands of consumers. So idea was to create legal and technical conditions for shipping companies to use these technologies in their normal, regular commercial operation. From our shipping companies, from ship owners, we've got 3 major topics, 3 major challenges. First, that these systems should be predictable and transparent for all participants. So it should be not like black box artificial intelligence, which is not predictable and understandable for other participants. The second point, that this solution should work within the existing international regulation, because all changes in international regulation would require years and even decades. And the third point, that they should be affordable. Otherwise, there will be no economical sense in implementation of this technology. As a common response to all these challenges, we have developed our own methodology, which is named as Complete Functional Equivalence Principle. We developed legislation and universal set of solutions, and we made extensive trials of these solutions within the normal commercial operation on board several vessels. 3 absolutely different vessels in 3 geographies. Tanker, oil tanker in Arctic, general cargo vessel in Mediterranean Black Sea, dredging caravan in Black Sea. So what is this complete functional equivalence principle? This methodology implies fulfillment in automatic and remote modes, all the functions which are currently prescribed to the crew on board. So independently to the mode of control, in traditional manual, in automatic, in remote, we are fulfilling, we are compliant to the all functions which are currently required by the safety regulation. As a ground, we took STCW code, which is already pretty functional oriented, and actually made this as a functional requirement to our systems. And based on this, we have developed actually for every vessel pretty clear map what could be done fully automatically. For example, here you might see that most of watch keeping and most of the functions of vessel control could be done automatically. Some functions mostly connected to work with people are dedicated to a remote operator and crew on board. On the one hand, this allows us to work within the existing safety regulation since we are compliant with its requirements. And on another hand, it guarantees that autonomous vessel interacting with other actors is guided by well-known and predictable rules and functions. I will not go deep into regulatory. I would just say that we are actively working in the International Maritime Organization in the analysis and development of international regulations for MAS, and taking into account this work within the IMO, we have developed national regulation. This is the first in the world regulation for autonomous vessels. We have 3 levels. The first is a federal law explaining, interpreting legal aspects of maritime autonomous ships use. The second is under law, including government regulations on the national experiment, which allow, as I said, to equip and to operate autonomous vessels under the Russian flag in commercial conditions. And the third level is technical regulation. First of all, these are recommendations by the Federal Agency of Maritime and River Transport on CalREX application by maritime ships. Again, first time in the world, the Maritime Administration explained in clear algorithmical mathematical mode rules for collision avoidance. Then we have also regulations, rules for classification of maritime autonomous ships and rules for cybersecurity issued last year by the Russian Maritime Register of Shipping. Also, as I said, we have developed a universal set of technical solutions. Universal, that means that we can apply it on any kind of the vessel, and first of all on retrofit vessel. So we don't need any new type of vessel. We can upgrade the existing vessel to the autonomous one with this technology. Again, you remember I said that we need to make it affordable, so we have utilized as much as possible the existing technologies. At the left side, you might see the mandatory systems, which are mandatory for all SOLAS compliant vessels, like navigation devices, radar, AIS, and etc. Technical systems, signaling systems, and etc. Also, we use already conventional systems like technical systems controls for unattended machine rooms. You know that vessels with unattended machine rooms do not require permanent presence of people in machine rooms. They could be controlled outside the machine room. So we just took this control center outside the vessel. Also, there are motion control systems like trajectory following systems, dynamic positioning systems, which can follow the road. And again, the only thing which we did, we sent commands to the system not only by human, but also by computer systems and by a remote control station. The only three completely new systems are autonomous navigation, optical surveillance, and remote control stations. They're implemented additionally to these vessels which I mentioned before, and these are actually the first commercial products which are currently available in the market. Autonomous navigation system is actually equivalent of the officer on board. It is integrating all the data from different sources, recognize dangers and hazards, and in accordance with CalREX, calculates maneuvers to avoid these dangers. And here you may see interface which is pretty similar to EGDIS. You might see that this is one of video reports by many trials made over the past year. So you may see that system recognized dangers, calculated maneuver, and then implemented the maneuver via commands to the actuators. Also, this autonomous navigation system provides human interfaces for crew on board and for the remote control station, for the remote operator. Then we have optical surveillance systems, which is equivalent of human eyes. In some experiments in different countries, companies are not using visual systems, but since we are following all the requirements by international conventions, and all international conventions require visual observation, we are using optical system as an equivalent of human eyes. So this system is automatically looking 360 degrees around the vessel in different ranges, in different distances, identify and recognize objects, and send data about these objects and their parameters in machine reading form to the autonomous navigation system. So it is working like an optical radar, and also as a video picture to the human interfaces, first of all to the remote control station. Remote control station, you may see here again one of the video records of one of the trials in real commercial conditions, is something like equivalent of a bridge, but outside the vessel. We have video screens representing the real-time video data with augmented reality, with metadata, which allow to which helps remote operator to understand the objects around the vessel. It has interfaces to all the systems, navigation systems, technical control systems, radio and messaging devices, and also joystick system to directly control the vessel. In general, we are following an approach that different modes of control should be coexisting. The same as it was made during Moonin project, as well as the same as it was described by the International Maritime Organization. So we are using the proper mode of control to the proper situation. For example, in high seas, the system could work in standard situations absolutely automatically. In non-standard situation, it could be controlled by the remote operator, and in some limited cases, like pilotage, for example, something like this, it could be done by the crew on board. Again, starting from the September last year, after extensive simulations, tests in simulators, we have started trial operation on board on these 3 vessels. The first stage was just gathering and analysis of the data, so everything was working, but without access to actuators. In December, we got approval in principle by the Russian Maritime Register of Shipping. Again, the first in the world approval in principle, approval for the autonomous navigation systems. And starting from February, we have started already full-scale test of automated and remote operation. Here you may see how it works. During the normal commercial operation, master just switched to the autonomous mode, and we are following automatic and remote mode.
Александр, парочка минут еще.
Yes, so this is the last slide, actually.
Just a couple of minutes.
Yes, actually, as I said, based on this trial project, now we are starting the national-wide experiment. During this experiment, shipping companies can equip merchant vessels with autonomous navigation systems. This vessel can get official category of autonomy. The crew can be decreased. All this is described in the regulation by the Russian government, which was issued December last year. So here you may see some of examples of the vessels which will be equipped very soon with autonomous systems and will become the first in the world officially commercial fleet by different companies. Autonomous, I mean, commercial fleet. So we are ready to share this experience, this practical experience, our technical solutions, our experience, how to deal with regulation, with class societies, and etc. with our colleagues from France. I believe that if you have interest to implementation of these technologies and making trials and commercial operation of autonomous vessels in France, it would be useful for you. So we are ready to share this experience. We are ready to support your efforts. That's all from my side. Thank you very much for your attention.
Thank you very much, Alexander, for this very interesting presentation. And for the French colleagues, I just want to tell you that autonomous vehicle is reality in Russia. In Moscow, you can see autonomous car in the streets, and Russia has a very more flexible legislation on vehicle autonomy, as we can see also in the maritime field. So it is very interesting, and it will be a great experience also for France. Thank you. And now we are going to listen to the French company Diota, specialized in augmented reality technology for the industry. Diota is a European leader in augmented reality for the high technology industry, and Sebastian Knodel, the managing director, will tell us about their application for the shipbuilding. Sebastian, the floor is yours.
Yeah, hello. Thank you for the introduction, and I just share my presentation. I hope it's visible to everyone.
Yes, we can see it.
Wait, it's not the right screen probably. Give me a second, just. Okay, I'm not sure if you see the right screen, but I just continue. Let me know if it's visible for you. So my name is Sebastian Knodel. I'm the managing director of the Diota GmbH, which is a subsidiary of Diota, French company. And I was actually director of research and development in the past at Diota for about 5 years. And then I moved actually to Germany and took business over here. And I'm also responsible for the relations with our Russian partners and companies, and directly linked to the French head office. And yeah, today I would be happy to share with you more insight into the IOTA's solutions, our approaches, our use cases, and especially our activities in the naval sector. And generally, IOTA is developing Industry 4.0 solutions to help companies to improve different processes in terms of assembly, quality control, maintenance, and others. Our clients are mainly in the heavy industry sector, aerospace a lot, automotive, but also transportation and especially naval. And yeah, just feel free to tell me if I talk too fast. And yeah, today I would like to share with you some of those examples. So can you see the next slide, or?
Yes, we can see it. It's okay.
Perfect. So the general idea our solutions are based on is that we want to bridge the gap between the engineering departments and the shop floor. So on the left side, we have the engineering, where all the data is coming from, and the design and the digital information is created. And on the right side, we have the shop floor with the shop floor workers. And what we want to allow with our solutions is to provide digital data more efficiently to the operating space, to guide workers by materializing the digital data in a very efficient way. And we want also to help them to better capitalize on this data to improve the operations, to improve quality inspection, to improve assembly. And this is very, very important. With the solutions, we want to allow them to capture information during the different processes they do, to capture the field data and reference them with the digital information, the CAD models, the digital mockups, and other information to create rich digital twins that represent the reality or a certain reality on the shop floor, and provide this information back to the engineering so that the engineering can optimize their data and their industrial processes. That's the overall idea, and what it actually should mean is what is illustrated in this video. So again, our solutions are particularly tailored for heavy industry and especially the data that they use. And our solutions for the shop floor are, we have a lot of experience with in the maritime sector, but also energy and aerospace sector, to provide very efficient solutions for the shop floor. So first of all, we can connect to different information systems in the engineering side to allow engineers use their complex CAD data or simulation data and then visualize it with the right device on the right place at the right moment on the shop floor for the worker. So here, the worker can see the interior of a cockpit through a head-mounted display. Or here, you can see how worker and assembly is guided through a projective system to drill holes in this case, but we also use it to assist for assembly of bolts and rivets, and not only in the aerospace industry, but also with different construction companies or naval companies. And here is another example of worker guided using a head-mounted display or a tablet actually during a maintenance operation on an engine, which is eventually engine of a helicopter, but this operation is very similar to operations with engines or complex equipments in the naval industry. And again, our solutions are also used for maintenance work in the area of for electrical components, for example. And finally, the solutions are also very well suited to for training purposes, to allow a faster skill ramp up of workers on the shop floor with complex information. And at the end, all this data that is captured and acquired is particularly well adapted to be provided back to the engineering so that the process could be improved and data could be improved. Here are some illustrations of clients that we have, and I think, as you can see, we are working with the DCNS, Navale Group, and also STX in the area of naval. So, yeah, here's an illustration of what I just described again. So on the left side, we have the engineering department where all the data procedures are developed and created. And on the right side, the field operations, and the field operations want to benefit from this data. And therefore, this data needs to be converted and manipulated. Interactive work instructions can be created and then displayed through different devices that we provide on the shop floor. So that, for example, for quality inspection, an engineer or a worker on the shop floor can compare the as-built status of equipment, for example, in the ship, with the as-designed status. So this is a very common use case that we have, especially in the naval industry, where workers on the shipyard want to move through the construction site and compare the state of the construction with the as-designed state using different devices. It's usually more tablets or head-mounted displays in such a scenario. And visualize this and document it, and document here the field data and create those digital twins that they want then to provide back to the engineering to maybe take conclusions and correct the construction eventually on the data. Here a quick look into the different devices that our solutions support. So our software solutions are completely agnostic to the different devices, and this is because we want to provide the best suited device to the worker. So our solutions, our software, the Diota player can run on tablets, it can run on workstations, it can run on a projective system or a head-mounted display. And this is because, for example, in a scenario where we want to assist an assembly, a worker who's assembling equipment or assembling bolts or other parts, they usually want to have their hands free. And therefore, they do not want to hold a tablet or hold a camera. And so they can use a projective system to project the information, or they can use a head-mounted display to have the information immersively displayed to them while they have their hands free and can do their work. However, for example, maintenance work, or for example, quality inspectors especially, they prefer to use tablets, for example, or these cameras to be able to interact with the system, to obviously being guided with a step-by-step instruction, but also to be able to take notes, document, and to execute conformity checks and create a very comprehensive reports of the build state of and then create those reports and then provide them to the engineering. And now maybe some words about some related use cases for the maritime, but also energy industry, where we have similar activities. In general, our solutions are used in the production and in manufacturing, and they are to assist the workers with step-by-step instructions, immersive instructions, where they can exactly see what should be assembled at which location at what time. Our solutions are used obviously also for quality control, where in quality gates, for example, an engineer can validate if the previous assembly was executed correctly. He can check. He will see the components to control displayed on his tablet, and then can check each of the components, clips, harnesses, or other electrical equipments, and can indicate easily if they are present or not, or if they are not correctly installed. And finally, for maintenance, this is very important. The worker is guided to the locations where the maintenance should happen, and exactly and receives very precise information how the maintenance should be executed, and this is also being documented. Here, general overview of how our solutions are actually used in an entire product lifecycle. So this is not exactly a naval maybe product lifecycle, but it's relatively general. So our solutions are actually very often used to validate and check incoming goods from suppliers, but also incoming goods for customers if it's in a maintenance scenario. And it's very important for those to qualify the state of the goods and to create an exhaustive report that represents the if the goods are in which state they are, because this can be compared when it's delivered back to the client. And then obviously, as I described, we can assist assembly operations, but also which we call in-process inspection. So during different assemblies, there are usually quality gates where the previous assemblies are checked, and we have tabletop systems or tablets that can be used to check all those states, create reports until the final inspection, which is then executed before the goods are delivered back to the client. And this actually can also be completely done automatic with a robot that will do this final inspection completely automatically. And now a little bit more focus into the marine industry.
Sebastian,
yes?
Une minute.
Okay.
Merci.
Where our solution is used, for example, in the naval group to increase the quality and especially to reduce the cost of reworking. It is used to actually control pipes for different stages in the assembly of the construction of the boats, where the inspection time is reduced and they obtain reduced quality. And now I finish with a little video that is more related to energy, but we have very, very similar use cases in the marine industry, where vessels or pressures or seal or other equipments can be inspected and documented, and different elements can be visualized here, and the worker can interactively observe and compare the as designed with the as built state. Maybe here, so another scenario of I think a vessel where or a pressure system, or here inspection of construction, absence presence of platforms, pipes, other equipments, and that if they are present or not. And here there's a more interactive visualization, which is basically in a shipyard, where they will visualize and compare the installed systems with the as designed scenario and document if it's has been properly installed, and confirm that and validate it. So this is some examples on tablets, but we also have here you can see another scenario with tablets. It's I think air conditioning equipments that are visualized directly on the construction site. And here we are on another construction site with a HoloLens head-mounted display that interactively visualize very different equipments, pipes, electrical components, electrical systems. It moves a little bit fast, but here you can see pipes that are installed, and the user can then see all those equipments on the right place and can confirm that. So yeah, so this concludes my talk. Thank you very much for your interest, and I can provide the slides afterwards for you, and obviously available for any questions. Thank you very much.
Спасибо. Следующий доклад.
Thank you very much. The next presentation is called Additive Technologies in Shipbuilding from St. Petersburg State Marine Technical University. And so Konstantin Babkin will present.
We are going to the second session of our forum, dedicated to the new technology to optimize shipbuilding, production, and life cycle. And we listen to Konstantin Babkin, the head of Research and Development Department of the Institute of Laser and Welding Technology. And he will speak about the additive technology in shipbuilding. The floor is yours.
Hello. Okay, let's begin.
Добрый день, давайте начнем.
My presentation today
Итак,
will be
моя
about
презентация
laser metal
сегодня
deposition
будет
technology and its
посвящена
usage in
лазерным
different
технологиям, аддитивным технологиям при использовании
applications in
на
marine
различных
and
задачах
other industries.
в морской
First of
и
all,
иных
some
индустриях.
words about
Итак, несколько слов
the
в
technology
начале
itself.
о
It is
самой технологии.
laser-based technology in which a robotized machine is used to deposit material, and we use powder, metal powder as a feedstock. So the deposition volume can be up to 1 kilogram per hour, and we can build pretty large pieces with this technology up to 2 meters diameter and even more. So here it is, a video of this process. It's speeded up, and the material we use here is titanium alloy, and the titanium sphere of 6 kilogram is built in about 8 hours. In summary, our technology is developed for weldable materials such as steels, nickel alloys, titanium alloys, cobalt alloys, and so on. We have large parts that we can build on site. The maximum diameter for today it's 2 meter diameter and 1.5 meter height, with deposition productivity up to 2.5 kilograms with steels. And the key of this technology is accuracy, so we can make precise blanks, precise work pieces with the minimum exit material for post-processing. So we also develop technological equipment for realization of this technology. So, for example, here is presented our most basic machine. It was built for 1.3 meter diameter and 0.8 meter height, and we can produce parts up to 350 kilograms here. This machine suits very well for most of applications in marine industry which we are faced to. So it's a part of propulsion system, different pressure vessels, and so on and so on. Past few years we develop our equipment, and now there is a family of LMD systems which can provide various materials, various sizes, and various applications. For example, our family covers a very big range of parts from 600 millimeters diameter up to 3000 millimeters diameter. All of these machines, they are laser plus powder based technology, but in nearest future, in next year, we will develop also wire arc additive manufacturing machines, so they can be presented in about a year. When talking of materials, we use metallic powders to produce large parts, and today we are working with a wider range of different materials. When we're talking of steels, it's beginning from stainless steels, 304, 321, 316, and so on, and hard strength steels also is used. We use a lot of nickel alloys, which are heat resistant, corrosion resistance. We can provide different bimetallic parts. For example, inside part can be made from steel, and outside made with different materials such as Inconel or copper alloys and so on. Also, we're working with titanium and aluminum alloys and different materials such as vanadium, molybdenum, cobalt chrome molybdenum, stellite 6, and something like metallic ceramics when nickel-based alloys is mixed with tungsten carbide. Most of our materials, we test them on site, and they show mechanical properties of rolled material or even better. It's much better than castings, but sometimes forging show a little bit bigger, gooder results. when talking about this technology and coming to the different parts that we can make with our machines and with our technology. First of all, we need to say that we making a blank, very precision workpiece which needs post-processing. And the process workflow is usually begins with a workpiece 3D model, which has some excess material for post-machining. It depends on type of part and what material we're talking about and what kind of post-processing will be required. And then the technological process that includes in itself some programming of our machine and the deposition process. So for today, the programming part, modeling part, it takes about 1 week per part, and the deposition, it depends on workpiece weight, approximately 0.5 to 1 kilogram per hour of deposition rate. It is common for our use. For example, this part which is presented here, it has deposited mass of 13 kilograms and deposition part time was 20 hours. And the whole production time of these parts, beginning with a 3D model and ending of deposited workpieces, it's usually takes about 4 or 5 working days, and we doesn't use any kind of accessory which is made specially for this part. So we use just a blank piece of steel like a substrate, and then we make a deposit workpiece. So this technology very good at low volume parts, which can be made very fast, and they doesn't need some additional work. So lead time, it can be decreased to 1 or 2 weeks. For parts which has large volumes, of course, traditional approaches such as casting and or forging and post-processing, it will be much cheaper. But for unique parts or for parts at which lead time is very critical, this technology suits very well. Also, we do a lot of works with design bureaus when they develop some kind of new equipment, and using of our approach can brings a very short delivery time, so it is able to test different designs during a very short time. After the workpiece is deposited, it goes into quality control. First of all, it's a geometry control. We use different 3D scanners for this, and also mechanical study, mechanical properties, some metrology and so on, which is needed to prove that workpiece is in specs. After geometry control, some kind of post-processing is done. Normally it's heat treatment for stress releases and for metal properties if it's needed, and post-processing with a mechanical equipment such as milling, turning or polishing, maybe handwork and something like this. And afterwards, the finished part goes to the quality inspection, and it's ready to ship to install in different equipment. When talking about the deposition process, so deposition, it's a welding-based technology. That's why there are a lot of stresses which is induced during the deposition process. And the key to produce precise parts is to simulate the stresses and distortion and predict them. Today we use abacus to simulate the process of laser metal deposition, and it gives us an opportunity to build proper good parts from the first attempt. For example, this is a titanium ring which has a diameter of 0.8 meter.
Константин, пару минут осталось.
Okay, хорошо. So the stresses, it gives a distortion of about 5 millimeter. We can compensate it and get a part of accuracy plus minus 0.2 millimeter on this diameter. So it's also information about the distortion prediction. So we can make a 2-meter diameter parts with accuracy of ±1 millimeter. And talking of different parts, we can produce titanium rings. We can produce different type of machinery equipment, stationary equipment or rotary equipment. We can produce parts of complex geometry within cooling parts, and came into the marine technology. We also work in a lot of propulsion systems. We use different materials, stainless steels, nickel alloys, copper materials to make different type of equipment. So this is one of the last tasks from the energy generation buildings. So the workpiece of about 2 kilograms, it takes about 25 hours to accomplish. So this was a brief review of our technology and equipment. Thank you for your attention.
Спасибо.
Thank you very much, Konstantin. And for the French colleagues, please note that Russia is a major supplier of materials to France, titanium, aluminium, steel, and so on. And of course, we see in Russia a very strong tendency on the development of high-performance powder. And I believe it will be a very beneficial cooperation project with our industry. Thank you, Konstantin. And now we will keep the laser technology field and listen to the French company Meliad and the CEO, who will introduce the innovative laser technology to optimize production and assembly processes.
Hello, good morning. So can you hear me first?
Yes,
okay.
okay.
Thank you very much for the day, for the participation. I will just share my presentation. So, sorry, I do not find the right. Okay, it's okay. Just a few seconds. Can you see my screen?
Yeah. Yes, it's okay.
You see the presentation?
Yes.
Okay. And I have 8 minutes or 15. What is the time?
8 minutes, please, Jean-Michel.
Okay, so
Thank you.
I have not too much slides, so that's okay. Just let me just. I already lost the time. Okay. Can you see my screen now?
Oui, on peut le voir. C'est okay.
Yes. So Meliad, we are a French company based on the west coast of France. And I will introduce you. We have 2 technologies, but first of all, we will concentrate on 2 laser technology. Basically, the first application we have, and we saw just before some information about stresses analysis. So we are also experts into stress analysis for fatigue life component, and we provide the equipment and service to control the stress generated by processes, and especially with additive manufacturing. We need to be sure that after stress relief, the stress is ready to zero. So we are providing engineering, measurement, and equipment to be able to qualify the stress relief or the stress, let's say, for the fatigue life. But today we are more interested into the laser technology. So we have application for laser surface cleaning and treatment, but also functionalization. And today the main target is to present you the technology for the surface cleaning and preparation. We have, let's say, huge customers in the field of aerospace and space. You know, all of this company. We have also some connection with now Russian helicopter, for example, or ODK. Probably Adrien can explain to you later on. But we are mainly in the business of shuttle, space, aerospace, and also power generation. Oil and gas and transport means a nuclear field for deconstruction, decontamination. Naval group, you know, for sure, for shipyards, but also for nuclear submarine. We will discuss later on, but also all the power generation, like Alstom, like GE, and other main actors in the world. And Alstom for example, for power generation and transportation. We are partner of a Clean Laser company, which is based in Germany. And now we are dealing with this company with manufacturing equipment in France, but also in the Russia market since February now. I will go into the explanation of what we are doing. So our competencies is just, you can see it on the top of this page. We are going from the studies, from the qualification testing onto real component. We are going to TRL, you know, the technological scale for validation for our customer in the way to put the technology in the manufacturing. We are doing for sure some services. And also we are going until the industrial solution for our customer. Plus, we said the robotization 4.0 means a fully automated and robotized solution. On the bottom, you can see mainly some application. So we have many applications into surface preparation before bonding to replace the blasting, to replace the chemical solution. We have the same for painting. We have also mold cleaning. We said also laser mirroring to remove the stripping onto the parts. Means today in the industry, aerospace, for example, you have a lot of manual stripping. And now we paint all the parts and we make a local decoating removal with automated solution. And we have also huge, let's say, business to come into nuclear decontamination and also in decoating or surface preparation before and after welding. And probably this is one topic we can offer to the, let's say, shipyards industry. I have some videos, so let me just start these videos. Oops. And I will explain to you how works the process. So you can see on top, you have the phenomenon is that you can see. Can you see the video?
Yes, it's okay. We see it.
Probably with some slots, but anyway, we have a focused laser, which is not a continuous laser as we can saw just before. It is not a continuous wave, it is a disconnected wave. We said pulse laser. And each beam is focused on a point, and you have a scanner inside the head, let's say the gun, the head, the optic, that move very fast and quickly the single point to surface. And then you can imagine to put this head with fibers, as you can see just behind me, onto a robot with a 3D camera in the way to make a fully automated equipment. So we have many kinds of application here. You can see some decoating onto gears. And we develop a process for, let's say, qualification to have the best efficiency with lower speed, if necessary, and lower cost. So we have, for sure, you saw some manual equipment. I will start another video. If it works, sorry for that. This was a nuclear development we made. So sorry, I have some issues with the video. Okay, we can follow. You can see here on the left some mobile unit. So we have different kind of powers, and the more the power is, the faster the process is. So basically, for each application, we decide to go with the best power and the best setup parameters. And for sure, I would like to see. I think it works. Okay. So this is the single process just to see you how it works. We have the single point that is focused on the surface, and then you generate a sublimation, and all the residues are always sucked during the cleaning. It means that during the treatment, you remove the coating, and also you suck all the residues. It means that at the end, you have only a small portion of residues to, let's say, to retreat. there is no pollution on the surface. So you can have post-treatment for the laser welding. You can have a pre-treatment, especially for shipyards, in stainless steel, in nickel base, for example, for submarine, if you want. We have also application for offshore, probably into the icebreaker in Russia. You have probably main interest for in-house, inside the shipyard, the local cleaning before welding, for example, or repair. So I would just want to show you manual application for decoating, de-rusting, and also automatic equipment. So I will move forward a little bit. Oops, this is not the interest. We provide also, so this is for decontamination, but full cell with manual cleaning or automated solution. And for example, in France, we have full equipment with manual cleaning for small part to remove the rust and the painting before to go in the shipyards to make a local welding. But we have also fully automated equipment, and we like to move with a fully process control with automated solution, as you can see here. Oops. So all the residues are automatically sucked by the head. So there is no pollution in the air, no pollution for the operator, no pollution for the part. It means that you can just clean and use it. For sure, we have, we have automated solution with a CAD file, without any CAD file, as we saw just before for the laser welding and cladding. And we developed also, so this is automated, there is a patent we developed to be able to have underwater treatment, especially for nuclear. It means that we can put a head inside the water and clean the rest for a typical application. So for the industrialization, we are going from, this is the laser base on the top. So automated or manual equipment with different kind of axis, or robotic solution. Case by case, we decide to go with robotic or let's say a cell with CNC and linear axis. For shipyards, just this is one application we made. For example, in this case of application, we have a fully, we have big panels, you know, for sure, with a primaire. We need to remove locally in the way to weld some stringers. And today, this was done by this machine on the right, the yellow one, with automatic brushing and automatic welding. And today, the project is to use, instead of to use the brush, is to use the laser decoating automatically directly onto the welding device. Like that. And also we have in shipyards equipment, means portable equipment to be able to make a local decoating before welding some stringers or some component, because everything is done, but during the designing you need also to modify some drawings, and you need to have someone with the gun, the laser gun, to remove locally the paint or the oxide and to weld the additional, let's say, plate or strings. Oops. So I think I am on time.
Yes, thank you, Michel.
It's finished. I have a last slide, but okay, that's it.
Great. Thank you very much, Jean-Michel. Thank you for the presentation.
Thoughtful presenter.
Okay.
And for showing that laser technology is fully operational, deployed in France, and I hope can be used in Russia for surface preparation technology. Thank you very much. And now we will go on innovative technological equipment, listening to Gemont Electric and to Anatoly Kulikov, the development manager of Russia of these French companies, who will tell us about the innovative power and propulsion system for shipbuilding. Jean-Michel, can can you close your sharing? We can still see your screen.
Hello, everyone. I need to share my presentation, so I'm waiting for it.
Jean-Michel, est-ce que tu pourrais te déconnecter, s'il te plaît? On voit ton écran.
Yes, but you have some issues. You have some issue.
Just me. I'm doing it.
Okay. I think it's okay, no?
It's okay, Nazoli, you should be able now to share your screen.
Okay, sorry.
Thank you.
Can you see it or?
Yes, it's okay. We can see it.
Okay. Hello again. Thank you for joining our presentation. My name is Anatoly Kulikov. I'm Gemont Electric Business Development Manager in Russia and CIS countries. Our company, Gemont Electric, is a French original equipment manufacturer of high voltage rotating machinery and frequency converters based in the north of France. We are working in many different market segments, but most important for today's session is the fact that we are on the world's leading suppliers for propulsion systems and energy generation for marine and naval applications. Later in my presentation, I will show you some references of the jobs we have successfully accomplished so far. Among others, the complete propulsion system on the helicopter carrier that we're supposed to sold to Russia in late 2010s. The Russian market for marine applications is therefore of highest interest in relation to our international development. Okay, how I can move it? All right. The history of Gemont Electric. Is it moved or? Could you tell me my presentation is working or not? Okay, I hope it is. The history of Gemont Electric. As you can see, we do have more than a century of experience. One major milestone in our legacy is our belonging to Gemont Schneider for some 30 years. During that time, we employed roughly 17,000 people, with more than 600 people in Soviet Union alone. Gemont Electric has a lot of unique equipment allowing the machine manufacturing of highest quality, efficiency, and best TCO ratio. TCO is total cost of ownership ratio. Here are some insights into our production and workshops in our France headquarters. In lamination workshop, we have the laser cutting line, vacuum impregnation tank in wiring shop. The tank has 5.5 meters diameter and one of biggest in Europe. The insulation made in the tank qualified up to 20 kilovolt. In assembling, testing, and balancing workshop, we have a huge balancing pit, able to balance a 900 megawatt rotor for a nuclear power plant in France. And you can see this in the picture. One of our major developments in the past was an invention of Gemont Electric Mactronics, a fault-tolerant, high-quality, discrete, multi-phase permanent magnet motor, which has positioned the company at the top of the electrical propulsion system market. Our engineers are specialized in marine architecture, and they are often designing the complete vessel's electrical propulsion systems, HVAC drives, or generation systems. Based on those highly developed engineering skills, we manufacture specifically designed machines and equipment, such as main propulsion motors, auxiliary motors, or for bow and stern thrusters. As an example, main generation and frequency converters linked with propulsion motors. To complete our system integration approach, we are working with external partners and suppliers such as transformers or cabinets manufacturers. The heart of electrical propulsion systems are frequency converters. On the picture, you can see three main parts of the VFD. Rectifier on the top. In this case, it is a it is diode front end. It converts the AC to DC. In the middle, you can see DC bridge. It is a DC capacitors bank. It stores energy and smooths the DC voltage ripples. In the bottom, we can see an inverter section. The inverter is generating a pulse with modulation patterns of DC voltage to create desired frequency and voltage to drive the motor. Most of drives on the market are from voltage source inverters type. However, the current source inverter topology is also used to better fit specific applications. Pluses of voltage source inverters: better dynamic performance, front-end design more simple so it is more reliable, ability to connect multiple motors to one single drive. Current source inverter pluses: well adopted to old motors, suitable for long cables, motor drive cables means. Better protection against short circuit in the inverter. No fuses needed. Our solution mainly based on wide range of voltage source inverter topology using high voltage IGBT components, and different configurations are available. On that picture, from left to right, diode front-end topology 12 pulses, diode front-end topology 24 pulses, active front-end topology, and plug-to-grid topology. Gemont Electric modular design allows replaces or repairs any parts of VFD within 1 hour because of withdrawal assembly of whole enclosure. Gemont Electric has many years of experience in retrofit and rebuilds project. We can incorporate into any control systems, and our equipment works with any SCADA, DCS, or PLC. You can see behind me a few references of Gemont Electric current source inverter retrofit. In this table, you can find the main parameters and dimensions of our VFDs. This is an example drawing of frame W3 enclosure for VFD with voltage 6.6 kilovolt and power from 4.5 megavolt ampere to 13.5 megavolt ampere.
Anatoly, 1 minute.
Thank you for your time. Please feel free to contact me for any additional information.
Thank you very much, Anatoly. And now we listen to Raphael Briere, the Managing Director of Bourbon Tech Solutions, which is one of the leading company supporting the offshore and not only maritime operation. Raphael, the floor is yours. Raphael, we cannot hear you.
Okay.
Now it's good.
Can you hear me, please?
Yeah. Yes, it's okay, and we can also see your screen.
Good. That's good. So I'm glad to talk to you. Thank you very much for your attention. My name is Raphael Briere, so I'm Managing Director of Bourbon Tech Solutions. I will introduce the company, what we are doing, but let me talk about maintenance. Let me talk about technical.
and especially savings, because we are focused on, I think, all of us on savings also, keeping the same level of quality for sure. So that's the purpose of this presentation. So let me first of all introduce you the company. The Bourbon Tech Solution is an affiliate of Bourbon Group, which is a world leader in marine services for oil and gas and wind turbines. Bourbon Tech Solution, being an affiliate, we are marine technical experts, and we are working. We are providing technical services to ship manager, ship owner, and crews. So basically, our daily activity is talking about maintenance, technical, and docking, okay, for vessels. And for sure, our satisfaction is obviously the peace of mind on technical for our customer. So let me share you a few words about our experience, what we are covering. So we are at the moment supporting from technical level the fleet of Bourbon in particular, but not only, but which we are talking about 400 vessels worldwide, working for the offshore industry, okay, oil and gas and wind turbines. So in a few figures, so we are 40 technical specialists. Most of us are quite experienced at sea already, so we are fully experienced, the field experience, and we have been dealing especially for vessel, offshore vessel, and we have been involved in quite some docking projects and docking specification engineering and so on. Okay, was the introduction of who we are. Let me share about the main topic of this. Okay, we are, dealing with this size of fleet, we are facing on day-to-day many challenges. The first one is, first of all, to increase reliability and availability of vessels. Okay, the second one, which is for sure, as you know, the most important, is to keep the safety awareness at the top level, because safety is first, as you may all know, and obviously to reduce the cost of maintenance and technical being the first center of cost for when of the OPEX operation of a vessel, and for sure we wanted to manage the risk, okay, on technical and operation. So this was our four main challenges we were facing too. So how are we going to do? We have decided to choose and to invest on a methodology that I will present to you, which is the RCM. RCM stands for Reliability Centered Maintenance. Is a way to optimize the maintenance plan, the maintenance process for a vessel, for an equipment, in particular vessel. As you may know, we have building the maintenance plan. By default, we take the maintenance recommendation from makers, but it is for sure good. It is enough. But there's there's a way to optimize it, okay, because they have plenty of overlaps and interfaces. So there's a methodology which is called RCM, Relatively Centered Maintenance, which is already well improved in the aeronautical industry, and that we have been developing the marine industry. And you're going to see it has given us, provided us quite some results, and I'm happy to share with you. The principle in the right is the following: is that we focus on we want to target the right level of maintenance for each equipment to ensure the cost, efficiency, reliability, and safe operation. The methodology is quite improved, as I said, and is the following: some question. We are looking at the equipment through the failure analysis. So we are looking at the failures, and then we are looking at one equipment, how can it fail, what are the causes, what are the effect of the failures, and then we can break down like a risk analysis, which allow us to take some decision with quite solid and where we are very confident, a decision on optimization of the maintenance plan. So I won't detail it as much as I can, but there are just keep in mind that there's a certified methodology which is led by a team. So a multidisciplinary team who is involved in the workshops. So the team is composed by a facilitator, which is certified, trained, and qualified, and many specialists such as process engineer, operator, mechanical, electrical people, and so. So we are doing workshops, and we are talking about one equipment, one by one, and we are following the previous methodology. This study, I mean, we deal equipment by equipment, and we consider having, I mean, spending from 200 to 300 hours per study or per equipment. And this methodology, this way of doing, is approved by class for sure. Okay, is reviewed and approved by class, and as told it, fully improved in the aeronautical industry already, and now thanks to many of us in the marine industry. So let me share you a use case, because this is the theory. Now comes the practical, the use case. So we have had the opportunity in Bourbon to do some to drive some 15 studies, okay, in 15 systems, 15 equipments. So here is the list: alternator, box cooler, firefighting, azimuth thruster, and so. These equipment were selected because they were strong leverage effects. So that means that sometimes they are redundancy. Okay, so you do one study and you got two equipment or three or even more. And most of the vessel has been identified, but because they are sister ships. So doing one study, we can, and with the leverage of the redundancy and the sister ships, we can impact, have a great leverage impact. Our technical team has been involved and trained for sure. And it has been very helpful for us to understand, to appreciate the risk of the maintenance that we are taking. Okay, so here is the system on which we have worked, and I can share you the return on experience. So the studies were driven in 2017. Or 18, now 2021, we did the return on expense. I'm very happy to share to you. On three equipments, we can say that we have saved, we have made visible savings. So what we have studied is the original recommendation we did were on 2018, and now the vessel went to dry dock. And we were able to analyze the cost, the real cost, the actual cost, and make the comparison. At the end of the story, and the comparison are linked to docking services, shipyard cost, service engineer, and spare part cost. Okay, so we end up with 14% of visible saving on one vessel for azimuth thruster only. We end up with 39% for the shark jaw and towing pins, which is a small amount, 33K for 10 years, but still it's a big saving for almost 40% saving. And the anchor handling and towing winch is almost 30%, 29. Okay, this is also this to be added, also the leverage effect, because we did this study on one single equipment, but on the azimuth thruster, there are several in the vessel, and there are several vessels in the fleet. So you can see and imagine the impact of the saving we did, and also keeping the same level of level of reliability, availability of the vessel, and it was a great success for us. So we will most probably, so we have driven 15, and we will continue in the next few years. But it was a great benefit for us. So as a summary, because I just focus on the key points there to show to you, and so that to be clear and straightforward. So it was a great benefit on safety, because I mean, everything has been reviewed. It was the opportunity for us to review and challenge all the maintenance plan, all the safety, and so to keep our safety awareness at top level. It was an opportunity for us to rework on the operational and to raise the availability and the reliability of the vessel. For sure, we did some cost reduction, which is not less important. You may, and some are raised up to 40%, 39, as you saw. And for sure, as a side effect, which is not the least, it was increasing the engagement of our people, maintenance people, which is, as you know, they are on board and they are working on the field and on dock. So this is very important that we care about what they do, and we help them to improve what they do. So this was our study on RCM, reliability centered maintenance, which helped us a lot to reduce the maintenance cost and to have all these benefits for the Bourbon fleet. I'm very happy to share this to you. Please do not hesitate to come to us if you need some more information, because now Bourbon Tech Solution is fully trained, experienced, and I've already great, results at this day. So we'll be happy to share more to you for sure. So please do not hesitate to call me if needed. Thank you very much for this, for your attention, and see you soon. Thank you.
Thank you very much.
Коллеги, слово предоставляется Центру технологий.
Dear colleagues, we are now giving the floor to the Center of Technologies of Shipbuilding and Ship Repair Works. Valery Kiriev is the director of Soyuz Project Verf, and the presentation is called The Project of Deep Modernization of Onezhsky Shipbuilding and Ship Repair Works plant to create the digital shipyard.
Yes, I'm there, and the time is a little bit limited. You only have 10 minutes.
Dear colleagues, we will listen to Valery Kiriev, the Deputy General Director and Director of the Soyuz project, who will tell us about the project of deep modernization of the Onezhsky Shipbuilding and Ship Repairing Yard.
Да, презентация видна, да?
Do you see my presentation? Not yet. Thank you, dear colleagues, to have presented me. Thank you to Professor Rojdestvinsky. And as it was previously said, I will talk right now about deep modernization of the Onega shipbuilding and repair plant, which is situated in Karelia in Russia. This is a small shipyard for civil shipbuilding. Valerie, we cannot see your slides. Can you share the screen? You can see this in the bottom of your screen. Can you see this button that is called share screen? It is in green. It is also called demonstration of the screen in Russian. Yes, I have my presentation on my screen. Yes, but we cannot see it because you didn't share it. So please. I cannot see my slides now. Can I do that for you? Is this your presentation? Yes, yes, that's it. Okay, you can see it, right? Yes. So, as you can see on this slide, the reconstruction of this plant is maintained according to orders of the President of Russian Federation. And the main client of this project would be Rosmor Port, which is state company that is the owner of this plant. The developer of integrated digital system is St. Petersburg Marine and Technical University, and executors of this project as for development of technological solutions and documents would be our Center for Shipbuilding and Ship Repairing. The aim of this project is to create a complex for small shipbuilding, and to reach these aims, we had to cover a number of objectives. We had to develop a concept of deep modernization. We had to develop a technical project of an integrated information system for digital shipyarding, and we also had to develop project documents. And we had to accord this with project organization and with our Russian government. As for principal technical solutions, we developed them on the basis of production program for company development. We talk about type ships here, and the concept to create digital shipyard was around 5 main blocks. Firstly, that was a compact shipyard principle. The second principle would be a transition from island automation to the integrated implementation of automated and robotic technologies. Then we had to implement a system of identification and tracing of materials and sources. And then we had to implement principles of pseudometrics, that we call them. And we had also to implement a dimensional control system on the basis of the most advanced software solutions. You may see it on this slide, and we created a number of new blocks for data analysis. We also created a compressor station and gasification station, as well as a horizontal shipway point. We also had documents to create painting and cleaning chambers, and to create optimized warehouse. So we will assemble a warehouse of steel, a block for mounting pipes, pipe working, pipe bending section, and so on. That will help us to minimize losses while transferring materials, and to let down the transfer of materials outdoors. So that will be 5 buildings, 5 sections inside one building. And the next block of a concept is to transfer from the island automation to automated and robotic technologies that will be integrated. We would like to make this while automating rolling station, while automating also the assembly and welding hull structures. We also want to introduce robotized lines, and we would like to install automated flat section lines. We also have to install laser equipment on the robotized sections. We also have to install cranes that will be managed by radio technologies. We also will introduce automated cranes with magnetic drivers. The third step would be the integration of identification system. This system will include automated imprinting for metals, pipes, details, and all the details of ships. So we will label unique identifications that will be read while producing equipment. That will help to see in automated regime the process of production and to minimize risks and human factors. To reduce the volume of works with new technologies, we have to introduce some metrics. New optical technologies will be employed, and we will automate control operations with unique digital data for all the facilities under control and all the equipments under control. We'll also create optical equipment to control transferring of technological elements. One of the main dimension of our work is to create a complex digitalized system to planify, to control all the system on the basis of the most advanced digital solutions. That was developed by St. Petersburg University, and we will create a digital shipyard that will be integrated into the information system of digital production that aims to create solutions for data processing, for technical planning and management, for management and engineering of electronic documents, for management of enterprise, and so on. To make this system function, we will create IP infrastructure that will include a data processing center, a structured cable network, a stationary and mobile workstations, a lot of printers, multifunction devices, industrial monitors, and so on. It will also include technical means of related systems and technological equipment. It will also include software part, that means enterprise management, and so on. We will also install architectural solution that we can see, and this project will help to create on the northwest of Russia a small plant, but that will be very modern shipyard to create not less than 10 ships per year and to treat about 10,000 tons of steel annually. We will increase its workload up to 400,000 cubic meters. It will be efficient and economically interesting. And last but not least is that this project is being already implemented. and we will finish it in 2024. So we will increase the level of this plant up to the leaders in shipyarding, and we will be happy to share our technologies to other Russian and international plants. Thank you for your attention.
Thank you very much, Valerie. And it is a very impressive and interesting 4.0 project in Russia. And we are looking forward to see it in real and to have French technology maybe implemented. Now we are going to have our last speaker of this second session, Mr. Thierry Guyot, the CEO of Navale company, specialized in drone services for the shipbuilding industry. The floor is yours, and please keep the time that we finish not too late.
Yes, thank you very much. Thank you very much for the opportunity to present Navale and what we are doing. I hope you see my screen.
Yes, we do. We can see it.
Okay. Okay, so Navale, what do we do? It's mine drone services. In fact, we are 3 co-founders, and we are coming from the side of the miners. We decided to use the drone to help in all the survey and maintenance of the vessels, mainly on the vessels. We were working, my 2 co-founders are miners, and they were selling for 10 years. For my side, I was more on the part of the maintenance, and we met on a project that was to improve the maintenance on board the vessel. And that's the way we met and we created the company. So what we do is we use for service the unmanned vehicle system. That may be aerial drones, but also what we call mini ROVs for some mines. So we can inspect outdoor. That's the easy one. We inspect also indoor. I will show you a short video to present what we can do, and we can also achieve surveys and maintenance underwater for the hull, for example. We are working also on different projects, innovative projects that may be for surveillance, or it may be for spraying with drones. I hope I can change to the new video. So the video is showing you for indoor survey. So we use a drone that is developed for that. You see that there is a cage around the drone that's able us to go inside a drone. So there we have to check the drone first to be sure that it's in good condition and that we will not have any problems. We just have to open the void or ballast, and we can go inside. That's in the situation where normally we need a lot of people to go inside in case of there is a matter. There the drone is going inside directly. We open, we go. On the left, we see what the drone is seeing. We can take pictures from the problems that the issue that we can see during the survey, and we can put that in a 3D model, for example, and we can compare from years to years what are the follow-up on all the issue that we have. Before that, the way we were doing it, we have to open, we have to breathe the air and change the air inside, and we can go, but from the bottom, from the very bottom, and we take pictures, or we could build scaffoldings, or we use rope access, or other things. So the drone here, it's very easy to use. We just open the box, open the ballast, and we go inside. The people are staying outside of the ballast tank, for example, and we can inspect. So we can do, and we follow up, show you what we can achieve.
with all of that. So I come back on the presentation. So we qualified by all the main class societies. We selected the main 6 class societies, and we went through all the process to have the qualification. So we are approved by all these class societies. The benefit for the clients, for sure, human risk. The drone is taking the risk for the human, so it's reducing drastically the risk that we are taking. Asset immobilization, we are much quicker than other aspects, rope access, or cherry picker, or even scaffolding when we have to build a scaffolding. So it's very quick. So we don't have to stop the vessel or the assets. It's not only vessels for long. So the cost is reducing a lot, obviously. The market that we have, we keep on what we know the best. It's where we are experts. It's in the maritime side. That's the reason why our clients, it's shipping companies or ports or maritime service provider, mine surveyors, oil and gas companies also. And we are coming to the marine renewable energies like wind turbines, offshore wind turbines, because we have all the assets to make the survey for that. I just want, because they say that it's a technical presentation, I want to show you very briefly what we can achieve with the drones. Here it's inside, we can do visual inspection, 4K video. So it may be a pipe, it may be a ballast, whatever you want. The drone is 40 centimeters of diameter. So if you have at least 40 centimeters diameter, we can go inside. Here on the left, you can see we have a pipe and we have some water and we are able to inspect it. We can do thermal inspection also inside. We can do photogrammetry, 3D modeling of what we are inspecting. May be useful when you don't know exactly the shape of what you have, your assets, and you can redefine a 3D model. Here you see a point of a cloud of points to rebuild your 3D model. We can do also real-time 3D modeling using the drone. The drone is going inside a tunnel, a pipe, or whatever you want, and we have the 3D modeling in live also. That may be useful in some cases. Indoor and outdoor, we can do also thickness measurement with drone. You see it on the left. The drone can rotate in the way you want, and you can take the thickness measurements. And thickness measurements, we can even take measurement when we have 3 millimeters of dust or rust. We can still keep a good measurement of the thickness. Like I said, it's very quick, but it's to give you an overview of what we can do. Outside, obviously, for 4K video, exactly the same. HD pictures, we can inspect cranes, so we can inspect wind turbines. We can inspect a lot of things, in fact. Thermal inspection, solar farm, for example, at sea, there is some, and we can inspect, again, all the thermal expenditure that we have on an asset. 3D modeling, we can do it inside, indoor, in confined space. We can do outside. Again, coastal surveillance, that's also what we can achieve. There is a VTOL, that means that the drone can take off vertically and land vertically, but after it's going and you can fly for 2 hours, follow some people or targets. You select the target and the drone is following the targets. Also, when you have some sites, on-site sensitive that you want to follow up, it's there autonomous flights. When you have something that is happening. Just push a button, the drone is going, and you can have the video back in live. We can do underwater. You see here some pictures. Depends, but we can inspect even in water where we don't have a good visibility, like under 1 meter of visibility, we are still able to achieve hull inspection. We can do more than just video inspection. We can do also NDT, thickness measurements, and sonar imagery, some kind of things like that. And that's it. Quick overview, because the time was short. If you have any question, don't hesitate.
Thank you very much for showing us how we can use drone and in the shipbuilding and for all the life cycle of the vessels. Very interesting. And now we will go a bit more on the north of St. Petersburg to focus on the Arctic regions, a new strategic area of Russia, and with the development of the Northern Sea Route development that can bring a faster maritime route for the global world. So our first speaker is Sylvain Faguet, the Chief Sales Officer from the D-Ice Engineering Company.
Good morning, everybody. I think you should be able now to see my screen.
We can see it.
All right. So I'm Sylvain Faguet, the Chief Sales Officer for D-Ice Engineering. Thanks a lot for the opportunity to present our activity today. D-Ice is an engineering office based in Nantes, created in the beginning of 2015, so quite a young company still. Our main ambition is to work on developing and producing clean energy, to reduce the greenhouse emissions of shipping, and to improve the safety and performance of ships at sea. So as you can see, we already had the chance and opportunity to work with some big contractors and oil and gas companies, very well known in France and over the world, but also with some shipyards and naval architecture offices. Our approach is really to apply a model-based engineering approach, meaning that we well model a system in order to well control it, simulate it, and develop the control systems. So as I mentioned, we have this expertise on modeling. Alpha 4 team is our PhDs and PhDs in applied mathematics or physics, hydrodynamics, controls. So we developed this expertise on modeling by first developing our own multi-body and multi-physics framework. This was a project initiated with the École Centrale de Nantes in 2016, which allows us to really model all the physics of a system, the hydrodynamics, the wind forces, the contacts, and all the behavior of a ship. We also work on the interaction of iced sea with structures. This we do it with a partner in Norway, Multiconsult, and one of our main clients with Multiconsult is Equinor, as they are working on an owner software for them. So here, really, the objective is to well understand the behavior of the marine platforms in order to develop or to optimize an operation, a specific operation, or to develop a control system and tune it and improve it. Some application of those multi-body, multi-physics approach is our in-house velocity prediction programs. So we have several sets in those programs, several level of accuracy depending on the client budget and where we are in the descent phase of the vessel. But this is really interesting for the integration of wind assistance within the propulsion mix of a ship. This is a subject which is quite sensitive since we have those International Maritime Organization regulations stating that we we have to reduce greenhouse gases emissions by 2030 and even more by 2050. So this velocity prediction program is based on the model of the vessel, resistance, on maneuvering of the vessel, on the propulsion setup, but also on the wind assistance system that we might have on board. Another type of application is the modeling of the ice-sea hull interaction that we work on. Here it's an example of project that we've been through with Multiconsult as our first client for Equinor. But the idea is here to work on the modeling of the type of fractures of the ice under the loads of the marine structures. Equinor uses it most for mooring design, mooring assessment of their FPSOs recorded in high seas. This is something that we could apply to vessels going through the ice sheet of the northern regions. Another topic that we have here at the ice is the weather routing. So we have developed our own weather routing algorithm. The idea here is we need to route a vessel from point A to point B, from port A to point B, taking into consideration the wave, current, wind, all the environmental aspects, but eventually also sun and high sea. We also work on a model of the ship, because at the end, the goal will be to find the route with the best energy efficiency, respecting the voyage duration that we have, the ETA constraint that we might have. Indeed, we want to take all the operational constraints that we might have, restricted areas or high density traffic areas, or other constraints more linked to the behavior of the ships. Eventually, we don't want the ship to roll more than 10 degrees, or for example. So the solution that we selected is a grid-based approach in order to do multi-objective optimization. And this is possible thanks to this approach, which is very flexible and highly tolerable. So we use the algorithm in different ways. We have developed and put on the market an online statistical weather routing tool, which allows ship owners, naval architects, or wind propulsion developer to run their own statistical weather routing studies in order to evaluate, to assess the benefits of a wind propulsion system on a ship. And this was used by different well-known projects in France, the Canopy project or the Navale project here in France. But this algorithm can also be used in an operational way with the weather forecast. Before, Satori was using the historical weather data, which are available. Kenavo is our operational routing service. Let's say you have a vessel that will depart in a few days from France to the US, and then we can start the routing support by calculating the best route to avoid bad weather, or to avoid, if we were going to the North Sea, iced icebergs, iced sea areas, and so on. The very last, the other expertise that we have, and that comes as the last brick of our expertise, is the control of ships. Here we really have this expertise from years of installation of system in our previous experiences. So we work on the innovative strategies to be applied to control ships and to control them more accurately and more efficiently. This goes through techniques of estimation with filtering of data and then control strategy to be applied. Non-linear strategies, or in order to feed our dynamic positioning systems or autopilot systems. So all these expertise, we gather them in our navigation system, Oceanics, which is really a cutting edge system for for the bridge officer. The idea was to bring together all the modules that the bridge officer would be using for the navigation, the route planning with weather routing, the EGDIS, which is the electronic chart display system for the navigation, and of course the autopilot or dynamic positioning if we have such type of vessel. All this is embedded in a marine grade hardware, and we have for the whole system DNV and BV certification. The idea here is really to propose a cutting-edge system to the mariners. And we had our first success for System Oceanics. We sold the first system to the vessel Canopy that would transport the Ariane 6 spacecraft from Europe to French Guiana for the launches. But also we sold our system on a small boy tender in France, and we have a partnership with the society Neptec, which won a call for tender to put two shuttles, one in Paris and one in Marseille for the next Olympic Games. Then we also have some research topics ongoing, and those research topics are to go towards autonomy at sea. The idea here, of course, is to improve the operations efficiency and effectiveness, and to reduce the carbon footprint of the vessel. We have some works ongoing on the detection. Okay, thanks. On the detection and identification of obstacles, and then the right control strategies to avoid those obstacles. And more locally, we are working also on automatic docking of vessels. So that was actually my last slide. So thanks again for the opportunity to present. And if you have any question, I would be happy to answer them. Thanks.
Спасибо. Thank you very much. Сейчас слово переходит Санкт-Петербургскому.
Thank you so much. And now we give the floor to St. Petersburg Maritime University. That will be Professor Oleg Timofeyev, who will talk about monitoring system for hull state and platform in frozen seas.
Thank you very much, Kirill. The systems of monitoring of ice effects appeared not from the very beginning.
The
systems of monitoring appeared, first of all, in the construction, in hydrotechnical construction several decades ago, for bridges, for different types of barrage. So these sites where we need to evaluate their state to be sure that it is safe to use them. Next slide, please. The application of monitoring systems can be divided into two directions. So there are two directions. The first one is the state control, the control of the state of this site, and also the preparation of exploitation solutions for maintenance, for repair works of different constructions and ships. And the second direction is getting basic information about external influences and for further engineering research and the creation of legislation for design and construction of ships and platforms. Next slide, please. To get the primary information, we use a lot of primary sensors. For example, the accelerometer, the vibration speed meters, different sensors, force sensors, So lately, we see the appearance of new types of sensors, optic sensors, the deformation sensor, for example. We are now using new sensors, the pressure sensors, which allows us to see the distribution of pressure for a certain surface, but the reliability of these sensors do not allow us to use them on real ships, so we just use them for our in vitro research. Next slide, please. Here you can see the standard dependence, the reaction of the ship to the wave action. So you can see different indications of rocking of an icebreaker. You can see that the wave action is developing step by step, and the ship reaction is also developing the reaction to this external action. The next slide, please. You can see here the reaction of the ship hull to the ice action. The wave action is a long-term action. It is practically a stationary action, but the ice action is another type of action. It has different impulses, and the time of this action is from 1 second to 3 or 4 seconds. So this is a specific trait of the ice action, and we need to take it into account. I will now talk only about examples from the Russian Federation, but the system of monitoring of ice action appeared in Canada, and we also need to talk about them. The first Russian ship equipped with the stationary monitoring system was the scientific ship Academic Fedorov, built in 1988, and this ship is still in operation, and there is a specific room where we have 32 measurement channels, one in the bow, the other one in the medium zone of the ship, and so a big volume of information was collected at this ship, and these data allowed to calculate the different charges and loadings for Russian legislation. This is the new ship which will replace Academic Fedorov. It is called Academic Troshnikov. This ship is already equipped with the monitoring system of the latest generation. You can see at the bottom of the screen the subsystems which make part of this monitoring system. Only on the hull we have 107 measurement channels, which allow us to cover practically the whole hull of the ship during navigation in ice waters. We have 10 additional channels, except 107 channels on the hull, and these 10 channels allow us to evaluate the state and the reaction of the hull to the wave action, for example. And we also have 8 channels which allow us to monitor the propulsion complex. And we also need to say that this ship has 2 shafts, and each shaft has a specific monitoring channels. Thus, this system allows to protect the ship from extreme charges. And here you can see one of the latest ships. It is called the North Pole. This platform is being constructed in St. Petersburg, in the shipyards of St. Petersburg. And we think that the expeditions on this ship will take 9 to 10 months. And this ship is equipped with some 200 sensors, 8 sensors to monitor the navigation of this ship in the space as a solid body, and also on the hull and on the propulsion complex we have 5 additional channels which allow us to assess the state of the ice environment during drifts. So we are waiting for the results of exploitation of this ship. Except these research systems, the Russian Federation has icebreakers which are equipped with monitoring systems. For example, 3 icebreakers were built under the project number 21900M, and they are equipped with the monitoring system with 20 measurement channels. And these are the monitoring systems for ice strike. Here you can see the figure on monitoring systems for the ships I've described. 3 of these ships are research ones, and the last one is the exploitation system, which allows the ship manager to regulate the speed of the navigation in ice waters. And now we will proceed and talk about shelf sites. We need to talk here about the platform Prirazlomne, which has a great number of accelerometers, seismic accelerometers, so they are very sensitive and they react to the movement of the platform. It also has different inclinometers, for example, and also the sensors to measure the porous pressure of the soil. 18 sensors located under the platform, and they show the measurements related to the bottom ground. And this platform also has 42 sensors for deformation measurements. At the shelf of the Sakhalin Island, we use the platform VITIS, which is a sort of combination of Malipak, a Canadian platform, and another construction, which allows to increase the depth of exploitation. All the measurement systems of Malipak are functioning. They are exploited in Russia. And you can see on the slide the main subsystems of the VITIS platform. We can measure the wave action. We have also accelerometers, the sensors of contact pressure, and piezometers for measures for other types of measurements. And this is a very interesting development which was implemented at the platform in Caspian Sea on the deposit called after Korchagin. And we've seen that this platform is very sensitive to the ice action. So specific elements of the platform were equipped with satellite sensors to register the moving of the platform. You can see here the block for living of the personnel, and the moving was up to 70 millimeters. We compared the measurements with the ice conditions and used this information to design new platforms. For example, the platform called after Filanovsky, which is used at the Caspian Sea too. And here you can see the comparison of monitoring systems used in the Russian Federation for shelf platforms, ice shelf platforms. There are 2 exploitation systems and 2 research systems. And what I can say in conclusion, the practical implementation of monitoring systems is implemented at more than 25 sites of marine infrastructure in the world. And we see that such systems are used for unmanned ships and constructions, where the crew cannot always control and evaluate the state of this site and make different decisions about emergencies, etc. Thank you very much. Thank you very much.
We are going, actually, it's a perfect transition because our next speaker, Gauthier Dreyfus, the CEO of Forum Robotics, will show us how we can use robotics for this kind of application that will be of great importance in the Arctic, the offshore, the maritime renewable energy, and maritime. Gauthier, the floor is yours.
Thank you, everyone. Hello, everyone.
Большое спасибо. Всем добрый день. Вы меня видите? Экран мой видно? Да, мы вас видим, мы вас слышим.
Gauthier Dreyfus speaking, CEO of Subsea, and I'm going to present you what we are doing in the field of automation, especially subsea automation for offshore wind farm. So Subsea, we are a French startup based in Paris, in south of France, and we are developing smart ROVs, so remotely operated vehicle, as the one you can see on the picture, to automatically inspect subsea inspections, especially for offshore energy markets. So clearly, wind farms and renewable is the key focus for us. So just as an introduction, what's interesting for a robotics company is the increasing volume of the piles that will be installed offshore. So you can see today almost 8,000 turbines are already installed in the world, mostly in Europe. And this market will be multiplied by 6 in the next decades or the next 2 decades.
Gauthier, we do not see presentation, if any.
Okay, should be better now.
Yeah, it's better. Thanks.
Okay. So yeah, this is our vehicle. This is the increasing market of offshore wind monopiles, like a factor 6, like I said. And what is very interesting is the repeatability effect. So in our mind, there is no robotics opportunity, there is no repeatability. And clearly, we are all coming from oil and gas markets where we had large interventions and quite complex interventions where offshore wind brings the opportunity to repeat the exact same intervention on several hundreds of monopiles. So there is a market opportunity for autonomy, of course, and robotics, for data valuation, but also for new business models. So what is subsea inspection in offshore wind farms? So basically, once the field is built, you need, of course, to maintain the field. And you have 2 types of maintenance. The key maintenance is at the top of the turbine. But let's say 1/3 of the cost approximately, or what we call BOP, balance of plant, and they are linked to the subsea inspections. So we estimate several days per year, per every structure. So typically, we need to perform cable surveys between the offshore wind monopiles and visual surveys. And this is exactly what our ROV can do. And you can see once you do one intervention, you can repeat it every time on every turbine. So repeatability is clearly the keyword. And to perform such intervention, we developed one of the most compact ROV in the world, very well adapted to offshore wind sites. So it's compact, it is smart. So the ROV is tethered. You have communication link all the time, but you have the ability to repeat the exact same intervention because it behaves like a drone. Everything is pre-programmed, and the ROV knows where it is, and he can navigate autonomously. So our ROV is particularly well adapted to light vessels, so non-DP vessels, but also light DP1 vessels, and soon CTVs, crew transfer vessels. This is one of our key aspects of the business model, is to deploy our ROV on a permanent basis on the crew transfer vessels. So you know that there are always these kind of light vessels that do the interface between the shore and the offshore wind farms. So foresee our model is to have permanent vehicles on every offshore wind site or every city. And to do so, and this is one of our key added value, is the ability to supervise in real time the operation. And this is why our keywords are smart and remote. To us, there is no remote supervision if you don't have any intelligence on the ROV. And why that? It's because you have latency and communication loss between your onshore control center and your offshore operations. So if your vehicle, which is subsea, is not able to behave by itself, or at least with the supervision, with the remote supervision capability, you won't be able to take the remote control. So we provide these kind of stations, and we develop the entire software suite and network suite as a plug-and-play device for your vessels. And an example, this is what we performed last summer in the North Sea. So it was an oil and gas site this time. So we managed to inspect several subsea templates, so subsea Christmas trees. So we were oil and gas, those production wells, and we inspected all the infrastructures at 500-meter water depths in the North Sea. All the waypoints were pre-programmed, but we had in real time the remote control link with a few milliseconds of latency. So we had pilots and inspection experts on the shore supervising remotely the entire subsea operations. Of course, we won't stop our development here. So today we have the ability to interface a smart ROV to a light vessel, and we are working as we speak on the new developments. And this is a roadmap towards offshore autonomy. Of course, everything related to the mission management. So we are pushing more and more plug-and-play software and intuitive software for non-ROV experts to pilot and deploy the ROV. We are also working on image treatment and artificial intelligence. And we just received a grant for a program to put a battery on the ROV and deploy the ROV as a fully untethered drone for a couple of hours under the sea. And this is an example of the hybrid ROV that we are going to deploy. So we have clearly strong interest in deploying technologies for remote supervision, but also fully unmanned supervisions. So our ROV might also be interfaced with what we call a USV, unmanned surface vessel. So we are working with a French consortium, and the solution will be released in the coming 2-3 years. And finally, I wanted to have a few words about what we are doing in machine vision. So we have a computer vision team here in Foresea. So we have the ability to track assets in real time. And at first, we developed this QR code tracking technology for subsea applications, especially subsea docking applications. But we recently released a product which is interfaceable to any subsea system or any machines. And we are working with oil and gas, defense, nuclear, civil engineering industries to track subsea assets in real time with a very accurate positioning feedback. And our system is easily interfaceable to any construction supervision software. And we have a qualification as we speak with the French Navy to validate and qualify the QR code system for a dynamic positioning of vessels. So it's still under qualifications, but the idea would be to have a QR code mounted on anything, and you could positionate your vessel in real time relatively to the QR code. So it could be quite a nice to have and powerful tool for light construction operations. So thanks for your attention. I'd be happy to answer your questions.
Спасибо.
Thank you, dear Gauthier. And I would like to give the floor to Maritime Innovations Company. That will be Anton Pleshkov, that will talk about modern methods for scanning. The floor is yours.
Good afternoon, dear colleagues. Please let me give me the possibility to share my screen.
Merci.
I will talk about contemporary methods of scanning of the seabed. I will talk about a part of the project implemented together with the foundation of the support of technological initiative of the Russian Federation. And this project was implemented with success, and it is developing. Furthermore, I will talk only about hydroacoustic parts used for scanning of the seabed. This type of scanning is important not only to solve engineering tasks, but also to guarantee the safety of navigation and the safety of different operations on the shelf and in shallow waters. What about the usage of such systems in the northern regions? It is even more topical because we are going to the regions with long maritime routes. These are the regions with big changes in flows, different volumes of sedimentations, etc. So the complex is made out of 4 systems. Each system can solve its own task. The possibility of their integration allows us to solve all these tasks at a new level. And these are the tasks related to bottom topography. Also, these are the tasks related to the maximum distance from the ship on the port hand and on the bow side. These are the tasks related with the identification and search for geological and anthropogenic dangers and threats, and also tasks related to the control of dangerous objects, unpredictable dangerous projects. For example, the temperature is going high in the Arctics, and thus we need to control different unpredictable objects. The first system is the inspection of side scan. We are now able to work with these systems in at an ideal level practically, and we think that these systems are competitive to other types of echo sounding machines with different rays, because this system is simpler. If we talk about the technical part, it is more reliable when we talk about low temperatures, and it allows us to solve the main tasks and the conditions of exploitation gives us better results. Just an example of comparison of works we made in the framework of tests using a multi-array echo sounding machine. You can see that our solution is not worse, at least, and it can solve the needed tasks. Another system is the broadband side scan sonar. In different conditions in rivers, in ports, we sometimes need to have more control, and to better control the seabed, we need to have a better swath. It is related to the fact that very often there are big changes in depth from several meters to dozens of meters. And if we also have the wind action, and if we have different mistakes in maneuvering, we can provoke an emergency situation, for example. So we were able to develop this system. And what is the difference in comparison to the previous system? We have a broad swath up to 6 depths, and the quality is good. This is just one example of the results of our work with such systems in the White Sea. And when we need to make images, it is easier to use such systems and not to spend a lot of time, especially when we talk about Arctic regions and when our time of function is limited. The third system is the perimetric side scan sonar. Its task is to identify the underwater structures. And we are now talking about geological issues. It is the gas infrastructure and the permafrost. Those two issues, if we have different distortions of the structure, some elements can go to the surface, and it can decrease the density of water, or it can cause a fast process of icing. So this system allows us to have different cross sections of bottom sediments and see if the situation is safe, or we need to implement some works to prevent dangerous situations. You can see that on the slide that we have gas which is going out to the surface, and so it can be dangerous for navigation. This is practically the same, but just in another place. And it shows quite well that the zones we are analyzing contain such geological threats and can be dangerous for our works. To get more accurate information, as all these sediments have a very good possibility to disseminate the particles. So we need to get the signals, very accurate signals for us to understand what we are working with. Are these light sediments? And we have examples of such processes. For example, sediments of the height of practically 5 meters, and they are moving for practically 20 meters in one day. And so it impacts the form of the seabed and the navigation process. Some other examples of such works, these examples are from the White Sea. You have a couple of minutes. Yes, thank you. So, for example, different unregistered ships or other geological threats. For the time being, we can identify them quite well, and we can send recommendations. The last part of my presentation, I wanted to say that we need such systems, and we use them, first of all, for the following. Unfortunately, we know very little about the places where we work. So there are different different currents, tidal currents, and other types of currents which were not examined. Here you can see the images from the bottom, and this is the same place. The time difference is practically 24 hours, but we see that the fairway is changed. This is the route to one of the ports in the river systems. So we see what changes are occurring, and for the unmanned ships, for the better automation of ships, we need to learn more about such issues. That's all for me. Thank you very much. Thank you for your attention. I am ready to answer your questions.
Speaking about the design of innovative marine drones from the French company Seabed and the CEO Antoine Thébault.
Hello, everyone. Can you hear me?
Yes.
Perfect. Yeah, I will share my screen right now.
We can see it. It's okay.
Perfect. So thank you for this opportunity to present our company. So I'm Antoine Thébault. I'm the CEO of Seabed. I will present you 3 different products and solutions. But first, I would like to say Seabed is a marine robotic experts. So we develop different kind of autonomous surface vessel. And the first one is, and the more important one for us in a way, is a tool to better monitor and survey maritime areas. So at first, when we start this project, we have different conversation with some actors in this field of observation of oceans. And today, the best tool to do this kind of observation is the space satellites. But if you want to collect different data under the surface of the water, those tools are not able to do that. So our job is to collect all the data between the surface of the ocean and the ocean floor. That's why we have developed our own satellites, but we call it satellite of the sea, because it's exactly the same spirit. So we are talking about a drone, a 20 meter long boat. So no one on board, of course, and fully autonomous. That means we are taking in our software different kind of environmental parameter, like maritime traffic, like meteorological data, things like that. And we have the boats will have the capacity to change the plan we update in at the beginning of the mission by itself. So it's a really 100% autonomous solution. And last but not least, it's an 100% electrical solution. So that's really important for us because with that we have the capacity to be at sea during around 10 months in total autonomy to collect different kind of data. That means our job is to collect data on really long period of time and on large areas. So that's our first technology. Maybe an interesting characteristic in terms of design. We designed this ship to be able to, we can mobilize it and operate it everywhere in the world really easily. We can mobilize it in less than 3 hours when we are at the first point of the mission. And we can transport our boats easily everywhere in the world. So that's also something interesting because when you need to deploy this kind of system, you also need to integrate this kind of constraints. So our long-term ambition is not to use our drones one by one, but more like constellations. That means a fleet of 5, 6, 10 autonomous surface vessels able to collect data on really large area. And our constellation will be operated on different kind of interesting zone. And our ambition is to deploy 300 autonomous surface vessels by the end of 2028. Some of the data we are collecting can be transmitted to our final customers in real time through satellite communication, of course. Not all the data, because it's sometimes really expensive to transfer data in this condition, but the more important data can be transferred in real time, of course. So today we are collecting more than 50 different types of data. A few examples here. Of course, we are doing we are collecting a lot of acoustic data. We have different technology around that. We are collecting data about pollution data, like oil pollution, radioactivity, microplastics, things like that. We can do photo, video, of course. We can collect some parameter around some topic like meteorology data. We can do bathymetry, things like that. It will depend on our customer, of course, and we can integrate different kind of sensor on board, depending of our customers' needs. Our business model is not to sell the boat to our customer, but to sell the data we are collecting. Again, it's a business model inspired from the space sector. So we are selling those data through big data platform we are operating. And but the thing is, we don't want to do all the analysis part of all the data we are collecting. So our customer needs to be to have the skills to do that. Or eventually, we can also find different kind of partners to do the analysis of our data. So we can do a different kind of things with that. I just took 3 examples here to just to give you an idea of what we are doing right now. So in terms of monitoring, we can monitor different things like halieutic resources, because if with our solution we have the capacity to better manage and better monitoring the stock of halieutic resources. We can monitor different kind of pollution and the impact of those pollutions on the maritime ecosystems. And one of the subjects we are working a lot is everything around the offshore sector, because we can do different kind of things like impact study, of course, bathymetry, but we can also use our vessel to for the surveillance of this strategic platform, for example. Another offer we are developing is around the topic of bathymetry, because it's really an important topic for us and for our customers. So the main idea is to develop a specific constellation of bigger ships able to do bathymetry for deep sea bathymetry. That's mean more than 500 or 600,000 meters deep. And the idea is not to use our ship alone, but to operate our ships around a mothership with a crew on board, a classic bathymetry ship. And with our technology, we have the capacity to observe a larger area, of course, and so to be less expensive than the traditional solution. So that's something we are working on really today. It's not moving. Yes. Okay. So today we already have 2 operational vessels. We manage different missions, mainly in the Mediterranean Sea, but we did some mission on different area around France. One of the main missions was a scientific mission, as an example. So here, what we can see is we use our system to observe different kind of cetacean with some passive acoustic technologies. So you can see the graphic is a group of 5 sperm whales, and we listen all this group during 5 hours near Monaco. And all the trace you have here is one animal. So we have the possibility to have the position of the animal, of course, and all the trajectory also of all the animals of the groups. So that's something we did. We also, during the mission, collect different kind of parameters also, but one of the mission is was this one, just to give you an example of what we are doing right with our ships. So we'll do different kind of mission in 21, 22. We will work in the near the Canary Islands with some Spain partners also. And in terms of roadmap, in a way, we plan to do our first mission in a constellation mode, as I presented earlier, in 2023. So we are starting the construction of new boats, of course, and this mission will be done around Europe and maybe French area, maritime area. So that's the first product, and the 2
Antoine,
other products.
Yes. 1 minute.
Yeah, I will be really short. The 2 other products are really different. We also are speaking of drones, but the first one is more for rescue at sea, and the second one is more for maritime works. So the Speed Rescue, it's the name of this drone, is used for different kind of situation. The good thing is it's an inflatable solution. So it's really compact, 100% electric. And with that, you have the capacity to save someone in a port. You can operate that type of drone from a boat, from the coast, from in a port, things like that. And the second one is more for maritime work. So we have the capacity to put around 80 kilograms of payload on it. So to integrate different kind of sensor for different scientific mission. So that's our three different projects. So if you want to have more information, I put some link here to see the drone in operation. And thank you. It will be all for me. Thank you.
Thank you very much. And our last speaker is Mathieu Keruel from the company Advanced Aerodynamic Vessels. Mathieu, the floor is yours. Est-ce que Monsieur Keruel est bien connecté?
Hello, can you hear me?
Yes, now we do.
Okay, sorry. So I'm going to present on behalf of Mathieu Keruel because he's not available now. So do you have a presentation, or should I use one of on my computer?
No, we don't have.
Okay, so.
And as we are already a bit late on the program, if you can do it in 5 minutes, it would be fantastic. Thank you.
Okay, I'll try. So share the screen. So can you see my screen?
Yes, okay.
So we are a company based in Nantes, created 8 years ago. The objective is to develop fast transportation workboats, so it's in a smaller sizes. So the idea is to go from 40 to 60 knots with vessels that are smaller than 30 meters long. This is something which is not that easy to achieve with the low fuel consumption that we want to be below 20 liters per pax per 100 nautical miles. And of course, do this within the existing rules and with the existing equipment without too many fancy or not reliable electronics, because a lot of workboats are operating in a remote area where electronics are not easy to maintain. So typically, if you want to realize this fuel economy at the moment, you need large vessels or foilers. The problem with foils is that the floating debris are a big problem, and so it's very hard to maintain in a and also the overcrafts with the propulsion in the air also are very expensive to maintain and very noisy. So this is the past solutions to go fast on workboats in the past, but they've been mostly stopped because of the maintenance and the complications for the owners. So the solution we developed is the passive sustentation. So we use, it's basically a plane that never takes off. So the idea is to use a wing to alleviate the vessel. So on this picture, you have 80% of the weight of the boat, which is carried by the superstructure. So we use air to alleviate the vessels instead of fighting against on like a conventional fast vessel. So above a critical speed, we have a reduction of the drag with increasing the speed, unlike conventional vessels, whose drag is typically quadratic or cubic growth with speed. So we developed a lot of design tools in high-speed aerodynamics, but also unsteady aerodynamics to qualify the vessel during the design phase. We also worked a lot on propulsion, because propulsion at high speed is a challenge. So most of the research has been carried out with numerical tools. So a lot of CFD and also mathematical modeling. So to simulate the maneuverability, but also the behavior in the waves. So we couple hydrodynamic model with the aerodynamic model in wing and ground to end up with the seakeeping model of the vessel. And we can see that the damping of the aerodynamic part of the vessel is very strong, and everything is happening as if the boat was much larger than it is. So in 2015, the first sea trials of the prototype, 10-meter boat with 2 outboards that we used outboards in order to be able to measure directly the thrust and so have the drag of the vessel in real time. So we could compare with the simulations and validate the numerical tools we use for all the vessels we design. So here is a comparison with between the measurements, the dots, and the predictions, the continuous lines. So in red, you have 10 knots of wind facing the vessel. So you have less drag when going upwind against the wind, because the elevation is stronger. And in blue, it's with 10 knots of tailwind. So you can see that as expected, the drag is going down above 35 knots. And we reach 55 knots on this graph. So here's the same plot, but with the efficiency, so weight to drag ratio. So you can see that we reach typically drag to weight ratio about 8 facing the wind and 6 in tailwind with these hulls, which is really good because a typical planing vessel is closer to 4 or 5. So we have much more efficiency, global efficiency than a conventional planing vessel. Then we optimized the hull for higher speeds. And so as expected, we had a little bit less efficiency at 25, 30 knots, but above 45 knots, the efficiency is increased, reaching 10 at 45 knots. So this is the maneuverability at high speed, which is really good also. And yeah, for 2 years, we've sailed more than 4,000 nautical miles without any problems on the vessel. So it's really reliable and safe with wave height up to 2 meters. So we have a yard where we build, so this is a 16-meter crew boat, which is now operating in Gabon, this boat. So 25 passenger, 40 knot cruising speed, 45 knot top speed. This is the inside. So everybody is facing forward. So just 3 rows of seats. So everybody is like a movie. So no seasickness and very comfortable to see forward. And this is a typical comparison with a conventional crew boat, existing crew boat. So with the same power, we go almost twice the speed. So the fuel consumption is half, basically. So it's $500,000 fuel savings per year per vessel. This is a 12-meter shuttle we built for Monaco this year. Again, a comparison. So the smaller the boat, the more extreme the fuel reduction. So typically we go from 40 liters per pax per 100 nautical miles down to 16 on this vessel and going faster. We are now working on larger crew boats for West Africa or Asia. And the fuel costs are also very largely reduced. Typically, it's cost per mile per passenger compared with a helicopter. So a helicopter is rented every hour. So the fuel cost, the total cost is about $7 per nautical miles. Existing crew boats are about between 2.5 and 1.5, depending on how many nautical miles you do in the journey. But typically it's about 1.5. And with the A2V, you can reduce this overall cost. So the boat plus the fuel costs. If you have the same boat costs, the fuel costs will reduce the cost per passenger down to 1, and even less if you use the boat to do 400 nautical miles. You can go lower than $1 per pax per nautical mile. So it's between 5 and 7 times cheaper than the helicopter, and 2 times cheaper than existing vessels. Overall cost to transport people on platforms. Thanks. Try to go as fast as possible.
Thank you very much. Thank you, Lionel. So we are concluding the third session dedicated to the technologies for the Arctic region and the Northern Maritime Sea route. And we are concluding our forum.
Ну, я бы хотел сказать, что мне кажется, очень интересно.
I would like to say, I think that this event was very interesting. It is our first experience with France, and it is called the first French-Russian forum for the shipbuilding industry 4.0. And it is true that there were a lot of solutions from the industry 4.0. I think that the Russian and the French presentations were very interesting. We learned a lot, one from the other. And I think that we already imagine that we will be organizing a similar conference later on. I would like to thank once again Adrien Denier for our cooperation.
State Maritime University of St. Petersburg for having been our partner for this first edition. And we saw the number of people has been very successful, and we are going to repeat it happily next year. I would like to thank you very much, Kirill. I would like to thank you, your team, and also special thanks for the team of Nokainov who worked hard on this forum, Polina Kazakova, our head of operation, together with us in St. Petersburg, and the team in Moscow, Elisabeth, Romain, and in France, Natalia and Paul. So thank you very much all. We hope that this forum has been very useful for the Russian companies to identify some new partners from France. And I hope that French companies see that Russia has a potential in the civil industry and to bring them on the Russian market next year.
Я хочу поблагодарить тоже нашу команду.
I would like to thank our team too. This is Dmitry, Tatiana, Maria, and the Russian participants who contributed a lot to this first forum. Alexander Pinsky, Marinette, Konstantin Babkin from our university, Valery Kireev with the project of digitalization of the shipyard, Oleg Timofeev with the systems of monitoring, Anton Pleshkov, who supports us quite often in the framework of such conferences. Thank you to everyone. Thank you for your participation, and I hope we will meet in the future.
Thank you all, and then see you next year for the second edition.
Merci beaucoup.
Merci. Merci, Kevin.